This video is going to teach you about the concept of limiting reactants, which is another application of mole problems. So we're not doing anything different in terms of the math. You're just learning to apply the concept of mole problems in a different way to answer different questions. So the idea of a limiting reactant is basically the substance that is going to run out first. You can't always have exactly the right ratios of quantities of materials to react. And so the limiting reactant in that case is the substance that runs out first. It is actually what controls the reaction, because if you think about it, once one thing runs out and is all gone, the whole reaction has to stop. It doesn't matter how many of the other materials you have. If that limiting reactant is gone, then the reaction is finished. So this is a video that's going to teach you about limiting reactants. It's also going to teach you about something called reactants in excess. Those are the ones that don't run out. So there are questions like, well, how much of the reactant excess did we actually use? How much didn't we use? And so forth. So this tutorial is going to teach you all about that stuff. And we are going to use the reaction that you see there on the screen. You're given 84.50 grams of iron 3 oxide and 53.67 grams of carbon monoxide to perform the following reaction. And we are going to answer all of these questions that are listed there. What's the limiting reactant? What's the reactant in excess? Because notice we only have two of them. So one of them is going to run out, but one of them we're going to have some extra of. How many grams of iron? We could have gone to carbon dioxide, but since iron's a solid, that's a lot easier to prove. So how many grams of iron did you make? And then to the two questions that I mentioned before about the reactant in excess, how much got used, how much didn't get used? So let's start with determining what's limiting. So there are two different ways that you can do that. And so to determine the limiting reactant in the first way, we're actually going to answer questions 1 and 2, what's limiting and what's in excess, pretty much simultaneously. So there's two methods. Method number 1 is what I call the have versus need method. So if you remember from the question, you have 84.50 grams of iron and you have 53.67 grams of carbon monoxide. That's what you're putting into the beaker, so to speak, in order to get the reaction. Okay, we've got to figure out how much of that would we really need. So to do that, what we're going to do is we're going to convert the grams of one reactant to grams of the other reactant. And so if you just found the amount of reactant that you need to react with reactant 1, then you can compare it to how much you were given, how much you have, and then you know if it's going to run out or not. And so here's the idea. Let me push this up a little bit because you can't see everything. Okay, so we're going to convert grams of one reactant into grams of the second reactant. This is the quantity that you would need to react with all of reactant 1. We already know how much we have, so you're going to compare those two. And here's the big idea. If you need more than you have, then reactant 2 is limiting. If you need less than you have, then reactant 2 is in excess. So that's the big idea, but it's always easiest to see an example. So let's do an example. Okay, so I just randomly chose to start with 84.50 grams of iron oxide, and I'm going to convert it into grams of carbon monoxide. So reactant 1 to reactant 2. So I just do a simple mole problem. I'm not going to go through that. I think you guys can follow that. Pause the video if you want to write it down. But what I found is how much carbon monoxide I now need to react with all of the iron oxide. So to use all of iron 3 oxide up, I need 44.54 grams. But I actually have 54 grams. So I have more than I need. So this is not going to run out. So carbon monoxide is my reactant in excess. Iron 3 oxide is my limiting reactant. Okay, so now I can conclude that since I have more than I need of the carbon monoxide, it's in excess, iron 3 oxide is limiting. Okay, so that's one way of doing it. Had I done the opposite, if I had started with the amount of carbon monoxide, 54.60 grams, and calculated how much iron oxide I would have needed, I would have come to the same conclusion. I would have needed more than 84.50 grams. That means that the iron oxide would still be running out. So regardless of which substance you choose to begin with, you're going to come to the same conclusion. You'll find what's limiting as well as what's excess. This is probably the harder of the two methods, but some students like it, some students don't. I'm going to show you a second method that may make more sense. Okay, so the second method is what I call just comparing amounts of products. So what you're going to do is you're going to do two separate mole problems. Now I know that's going to feel like a lot of work, but actually in the end, it saves you a little bit of time moving forward. So you're going to do two mole problems where you're going to convert each of the reactants, reactant 1 and reactant 2, in this case, both the 84 grams of iron 3 oxide and the 54.60 grams of carbon monoxide, into product. Since the question, one of the questions originally was how many grams of iron, I'm just going to go to iron because I'll be able to answer that question when I'm done with this. And I'll be able to see what's limiting as well, because the limiting reactant is going to produce the smaller quantity of product. If I have more than, if I see how much iron I can get from the reactant in excess, it's going to be more than what the limiting reactant could produce. So again, I'm going to do two mole problems. One is going to be from iron 3 oxide to iron. The other one's going to be from carbon monoxide to iron. And these are my given quantities. Those are the two quantities that I was given at the beginning of the problem. Okay, so now I'm going to compare those. So the iron oxide can make 59 grams, but the carbon monoxide can actually make 72 grams. So iron oxide is going to run out first, because once 59 grams are made, iron oxide is gone. So the smaller quantity of product is coming from the limiting reactant, and so that's what I know what's limiting. So now my conclusion can be, since iron oxide produces less iron, it will run out first, so it's limiting, and carbon monoxide is in excess. And like I said, the nice thing about this second method is I've also answered question number 3. How much product can you make? Look at that, 59.05 grams of iron. Okay, so far so good. Okay, we're going to move on to some other parts of the question. So had you done the need versus have method, you wouldn't know how much iron you can get. So step 3 for you guys, or calculation 3 for you guys, would have been this. How much product can you make? Well, I know that my iron oxide is going to be limiting, so I'm going to use that and figure out how many grams of iron I can actually make. So that calculation is actually the same as this one that we did to figure out what's limiting. So I have the same answer there. Okay, so that answers 3 of our 5 questions. That deals with the limiting reactant, how much is running out, and how much product you can actually make. From here on out, now that you know what's limiting, you always want to start problems with that limiting reactant, because that's a given amount. You don't want to use a calculated amount unless you have to. So that's why you're going to see me do what I do in the next couple problems. Okay, so step 4, how much of the reactant in excess got used? Okay, well, you're going to use the limiting reactant in a mole problem to find out the mass of the reactant in excess that will react. Now here's the nice thing. If you did a have versus need method and you chose wisely, you actually have answered that question. In this case, I chose wisely. 84.50 grams is my quantity of limiting reactant. And I actually already converted to how much carbon monoxide would I need. So I already answered the first question, or the fourth question, by doing the have versus need method the way I did. 84 grams of iron 3 oxide is going to produce 44.50 grams of carbon monoxide, or is going to react with 44.50 grams of carbon monoxide. That's how much gets used. Okay, and like I said, you might already have done this calculation if you're using method 1. So one way or another, hopefully, you don't have to do all of these mole problems. Hopefully you've answered a previous question at some point that lets you not have to do every mole problem that you see me have written down here. Okay, so now that I know that I'm using 44.53 grams of carbon monoxide, how much didn't I use? Well, hopefully you can figure out that's a simple subtraction problem. I'm going to subtract what I was given from what I used, and so then this is the quantity unused. All right, and that's all there is to it. So you've got 5 steps to do. First thing you're going to do is figure out what's limiting and what's in excess. One of the two methods. You don't have to do both of these. You don't have to flip-flop between both of them. Use whichever one you are most comfortable with. A lot of students prefer compare the amounts of products because it's pretty straightforward. For some students, the have versus need thing gets people confused. So if you don't want to do that one, feel free to do the method number 2. Once you know what's limiting and what's in excess, you've got 3 more problems to do. How much product can you get? Starting with the limiting reactant. How much of the reactant in excess gets used? Starting with the limiting reactant. Please notice that you're always starting with the limiting reactant. And then finally, to figure out how much didn't react, you simply subtract what you were given from what you used, or what you used from what you were given, and that's how much is unused. So this is waste. This is bad. You know, you want to kind of figure out beforehand how much of each reactant you're going to need to use, so maybe you don't waste 10 grams of this. You know, working in industry, your bosses might not be happy if you waste a whole lot of stuff every time, so it's useful to know that information. All right, well, you've got a couple problem sets to work on. Good luck with those.